Hello, can I get everyone's attention, please? We're probably gonna get started now. Um, Thank you. So hello, my name is Jacob, as you heard from Clemens. I'm currently a second year comp science student here at Cal Poly Pomona. I'm here joined by the illustrious
Felipe, I'm the treasurer here in Swift, senior, and we're going to teach you guys intro to networking.
Cool. But before that, you should become a member. Swift is a very cool place. You get the benefits of being a member is that you get cool swag, t-shirts. T-shirts are pretty cool, and you get to honestly be just more involved with our community. I'm pretty confident in our community. We're pretty close, maybe a little too close, but yeah, we're pretty cool. But yeah, obviously we have like these capstone projects like Red versus Blue and Tech Symposium. Tech Symposium's happening next semester, but Red versus Blue this semester, run by the wonderful Clemency. But yeah. So here you are in Intro to Networking, which is the second general meeting. Last week we went over orientation. You got to know some of us, talk to some people. Talking to people's cool. Yeah, so this week is mainly going to be on networking. More fundamentals of it, just what you need to know to actually comprehend what's going on your network. And yeah, they'll accumulate into this really cool workshop we have, right? Yeah. So previously, we had introduction to the virtual machines, right? You won't need virtual machines for this week. It will be on our infrastructure, and hopefully if it doesn't blow up, it'll work. Yeah, it'll be really cool. So if you have a web browser, you'll be able to do the workshop. That's all you really need. If you have a web browser, we'll try to find a way to get it. Yeah, so here's the topics to be covering today. So first off, what is networking? Why does it exist? And then we'll go into the idea model, sort of the more conceptualized parts of networking, and then support some of the stuff you're going to need to know for Friday's workshop. If you miss this workshop, you can probably still catch up on Friday, but this is just sort of give you that foundation. You need to actually start understanding what happened. So I'll hand it up to Felipe. All right.
Once again,
We're going to start off with networking. And it's everywhere. But just start off with a question to the audience.
you know why is networking important? Okay. Want to take a shot at it? Yep.
Everything. What was that? It connects everything. Yes. Pretty much. Yeah. There's it's networking because it's obviously like I said everywhere, from public to private to government sectors. It helps us.
It helps us
Finish class, share resources. Just like what we see here in this diagram, well, this diagram we kind of go by what's called topology or networking topology. And although it sounds pretty, or it looks
pretty overwhelming, we'll break it down bit by bit, and you get to start to understand each concept or each icons. Like for example, these are laptops or endpoints that we like to kind of explain it. And these boxes are switch, which helps kind of users share resources. And then these round icons are like routers. As these are also endpoints, but these are servers that share resources, internet, and a firewall. But we just kind of showed you just a pretty overwhelming topology, but we're going to start off with a very simple one. And this is a star topology. Pretty simple. It's just a switch in the center. And I'll further explain what a switch does, this networking device. But it basically enables the users to share accesses or ways to communicate with each other. It is a pretty viable system. The only issue with it is if it kind of shuts down or cuts power, or someone just decides for some reason smashes switch, we can communicate with one another. And this is kind of like just the house icon. This is kind of like to show you that this can happen like within a household. All right, now we're moving up with a bit of a larger scale, which is a ring topology, and kind of self-explanatory. These are like networks within the houses that kind of for this scenario we can show that or state that they're trying to communicate with one another. Who knows? They're all great friends, neighbors, and with these arrows, it shows that the data is rotating in a counterclockwise way. This is just another viable way to share data or resources. The only thing is that if one of the houses for some reason crashes in regards to networking, then it kind of stops the cycle in regards to like data sharing. And then we get into a more complex topology, a mesh topology, which it's obviously it's a large scale, and it's basically showing like for this point or this point of view, this house connecting to this one, to that one, to this one, and to each house. If they really wanted to share that resource, it is a very complex, obviously, topology. And the cool thing about this, or I guess this safe option about this, is that if this house or networking kind of shuts down or just, once again, crashes or anything, and if they try to send data, this one, obviously it won't successfully share it, but they can share it from within other houses or networking devices of that topology. All right, so we kind of explained just the topology, but there's these devices that we discussed, and like I said before, a switch is a network device that enables users or web servers, just end users or endpoints, to share resources and connect and communicate with one another. Firewall, I don't know if you've seen the previous one. This brick wall, we describe it as firewall because it lets the user create rules to enable and or disable or deny outbound, inbound traffic or connections. And it is just a good form of protecting yourself. I wouldn't say to heavily rely it, but it is a good form of practice to make sure you're pretty safe or you're denying any unnecessary unauthorized access in regards to networking. Modem, it is another network device that helps communicate the user with either a printer or any form of other network devices. It sounds very similar to a switch, but the modem, what it does is it kind of encodes or codes the message or the data or the packet, and it modulates the packet kind of once it is modulated or encrypted, it shoots out the message to wherever the destination's at, and then the receiver does the kind of like reverse thing of it, so it demodulates, and let's say it's a file, then they can read the file successfully. Routers are network devices that help you gain access, well, not gain access, but communicate with another network that's kind of out of reach to your network. So for example, here, let's say that this user is trying to get access to, let's say, either the printer or like the web server. And obviously we just have this switch that connects to these 4 host machines, but we have this lovely device, the router, that will help us connect to this switch. And let's just say we do have access, or the firewall does let us pass, then we can get connected to this server and gain access, whether it's a file or any form of content in regards to data. And access points are kind of like routers, because we kind of know them as a device to share Wi-Fi access, but it's just way to kind of extend the range of a Wi-Fi connection. And it's just pretty much like that, plain and simple. Another like lingo terms in regards to networking, nodes are basically end users or endpoints of the topology. So this is a node. All of these at the end are nodes, as well as network devices. So it's just another way of explaining network devices as nodes. But endpoints are actually the devices that are at the end of the diagram of this topology. So this web server, the web server, server, these laptops, the printer, this icon looks a little funny, but it's a kiosk. So those are the endpoint devices. A gateway is very similar to a router, but it helps you, or it assists the user to gain access or to reach out to another user that is not kind of within their local area of network. So let's say it's trying to reach out to the server, well, it would get in touch with this router. The switch will get in touch with this router, and the default gateway assists the user to reach out to this switch network device. And if all goes correctly, they can then contact or come in contact with this server. And then interfaces, or NICs, or well, NICs stands for network interface, are a part of a PC component that helps the user to get in touch or get connected to the network. And there's two types. I think a lot of us who use PCs use a Ethernet or a physical Ethernet NIC, and that we have to plug in the Ethernet cables from whether it's a switch or a router. And there's also wireless NICs, which obviously our phones, laptops, tablets have built in, and that's how we can get connected to the Wi-Fi. NICs, I'll lightly touch on it, but NICs also have a form of identifier which is called a MAC address, which is a very unique ID that people use to identify their devices. But that's all I say, because my partner in crime will further explain MAC addresses. But just kind of like I discussed before, these are endpoints, and just to kind of give you a visual understanding of this topology. These are switches, these box-looking icons, routers, and firewall. And so now that we've kind of got a good understanding of the topology and the network devices, we're going to go now in regards of, or move forward with the TCP/IP model. And so we have this topology here, a very kind of minuscule scenario. So my boy Eggvan is trying to he's using his laptop, and he's trying to get some nice I'd say rich content in his website called the Security Catalog, and I highly recommend to look it up if you want to further read about offensive protein stuff. But the TCP/IP model is going to let us further understand what is happening within the network in regards to like action, purpose, and in regards to the activity of this topology. So Eggvan is trying to get in touch with this NoSecurity.blog web server. If we kind of go to each layer, we understand that this layer or this application is gaining access to HTTP, which is one of the services in regards to the application that to the transport layer. There are two kinds, and I'll lightly touch on it because once again, Partnergram is going to further explain it. But TCP is as compared to UDP, very slow, but it's very reliable, and that's all I'll mention for now. And as we go further down into the TCP/IP model, we get more into the network layer, or the layer that network activity happens. And the network layer, actually, I'll pull this up. The network layer, we use a thing called an IP address or internet protocol. Since we're just discussing about the topics, we'll talk about just the IP address. I mean, there's two forms of versions. There's IPv4, IPv6, but we'll just be discussing about IP address, or AKA IPv4. And it's just a way for a host machine, or for, let's just say, AVAN, since he is reaching out some out of his switch network device, and he has to utilize the default gateway and this router to reach out to a remote network. The IP address will be utilized so that the nosecurity.block can also reach out and get in touch with AVAN. As for the data link layer, the MAC address, let's just imagine that there's these other devices that are connected into the switch device, and the MAC address is just a way, or we will utilize the MAC address to identify each host machine. So let's say Jacob is connected, or Chet Apachard is connected, and AVANS wants to get in touch with him. Well, they'll utilize the MAC address so that they can get in touch with that device. And then the last layer, or the last one, is the physical layer, which is as kind of a bit self-explanatory. Is the physical layer is what connects the host machine or the network PC onto, let's say, for like the switch, and it seems like electrical currents, maybe a high frequency current, can be translated to a ones, or no current at all can be translated to zeros. And this is just a form of sending that message and that data. And then, if we were to, now that we kind of broken down the layer, we can see how from one machine creates a message and then sends it to another endpoint or machine. And these numbers kind of indicate what layers they're located at. For application layer, it is 5, transport layer 4, network layer 3, data link layer 2, physical layer 1. This is kind of the what's it called? Very like starter layer in regards of like networking, or trying to understand networking, or learning about networking, because there is another one that is called the OSI model, which is a bit more complex, because the difference between the OSI and TCP/IP model is that you can, by comparing them, we see that they're very similar, but when it comes to application layers, the TCP/IP model kind of just keeps it just that application layer. As for the OSI model, it breaks it down to 2 more steps. So session, presentation, and then application layer. It's just a more sophisticated, more dissected model. For good starters, obviously, the TCP/IP model is one to first start off. But if you want to get more sophisticated, or understand how things break down into sections and activities, then the OSI model is also the next good step in regards of networking. They do help like network technicians to kind of identify what the problem is at, because if, let's say, you can't connect or anything like that, we're not just gonna sit there or stand there and be like, well, it's not working. We can try and utilize this model to kind of see where the problem or situation is occurring at, which layer it is, whether it's TCP or the network layer, transport layer, data link, so on and so forth. It's a good tool. But that is it from my end. I'll pass it off the mic to Jacob.
Oh, thank you, Felipe. So in this section, we're going to be talking about addresses, protocols, and ports. Addresses, because that's how you identify devices on your network, right? And protocols in that, how are we following these rules in order to actually communicate with each other? And ports, what kind of services are we running on these computers? Because that's also part of network, because you can also identify services through that. But yeah, so first thing I'm going to talk about are what are addresses. So usually with a computer, you're going to have, you're usually going to have two addresses. You're going to have a MAC address and an IP address. So I like to, I'm not sure if we had another analogy, but think of the MAC address as sort of the VIN number of your car. It comes with the manufacturer and it's supposed to stay the same the whole time you have the car, right? And then the license plate as the IP address. You can interchange it whatever you want. So the MAC address isn't supposed to change. It's supposed to be unique to that device, which is why we use it at layer 2, which I'll talk about later. But the IP address, you can interchange it with other IP address. You can change that. That doesn't necessarily mean you can't change the MAC address. There are ways to change your MAC address. You're not supposed to do it, but there's things called MAC spoofing. So for example, as Felipe was talking about earlier, the default gateway, right? That's how you get out to the internet. So if you want to access something outside of your network, you go to your default gateway, and you're going to have to use your destination MAC address for that. And what an attacker can do is find that MAC address and use that MAC address as the default gateway. So all the traffic that you're sending out to the internet is actually going to the attacker. So you're not supposed to change the MAC address, but and just know it's supposed to be unique to that machine. And when you guys, if you want to do the Wireshark workshop, you have to be able to distinguish between what a MAC address looks like and what an IP address looks like, which I might show later, but don't worry about that for now. But yeah, so as Felipe was talking about earlier, at the transport layer, you have two different protocols, right? Can anyone tell me what a protocol is or what it means? Yes.
Set of rules.
A set of rules, right? And why do we need rules? Why can't I just do whatever I want?
To avoid chaos.
Yes, which is why we have these rules set in place. So this is why we have UDP and TCP. So TCP is slow but reliable, connection oriented. So it makes sure the data gets to where it is. Where UDP is connectionless, fast but reliable. So it sends it and forgets it. Example of this is in my comp sci class where I write code and I write really funny comments that aren't supposed to be on it, but I don't check my code when I turn it in. So that would be unreliable, right? But if I was more on the TCP side, I would actually check my code. But usually you want to use TCP when you want to receive everything, right? And then this is why we use TCP for websites, right? You don't want parts of the website, right? I want all the blogs from nosecurity.blog, not just some of them, right? But UDP is more if you're doing like something live, you want the data quick, so like live streaming or live gaming. But yeah, as you can see from this picture that I got from the internet, UDP is very messy and it's just sort of pouring it all over, and TCP is making sure all the water is getting into the system. But yeah, it's not even that funny. So here's another question, really cool question. Can a computer run both DNS and a web server? As Felipe was talking about earlier, DNS is just translating those domain names to IP addresses, so you don't have to remember those IP addresses. So basically the question is, can a computer run more than one web service or run more than one service?
Yes, very much yes.
Yes, and how does it do that?
It stores them in separate processes.
Right, so you can access them through different ports, right? So you can have multiple web servers on different ports, and that's how you identify different services running on the machine. And that's what ports are, basically identifying specific running services on a machine so you can access different ones. So for example, I have web browsers on the common port 80. As you can see, we use a different transport protocol for TCP and UDP. SSH remotely accessing a machine. So if I wanted to go into another machine and run commands on it, I could use SSH. But yeah, and DNS, what we talked about earlier. But yeah. So I'll be walking you through a connection because specifically for the Wireshark lab, it's important to know who's sending information and who's receiving, and being able to identify those devices associated with those addresses. So as you can see, another example is Egvin visiting the Epic website, nosecurity.blog. We're going to identify source, destination MAC, source, destination IP, and source port and destination port. So first thing is we're going to put in our source MAC. So Egvin is going to have a source MAC address of 888 because that's him, right? Does anyone want to tell me what the destination MAC address would be then?
A bunch of these.
Yeah, good job. I'll let you guys redeem yourself on that. What would be the source IP address if Egvin was trying to get to nosecurity.blog? Yes, and whoever was talking, yes. And then destination IP is it's pretty straightforward from there. Does anyone know the common port for HTTP? I don't know.
It's port 80.
Yeah, you're so smart. And anyone want to take a crack at the source port? What will Egvin use as the source port? No, not you. E5. 62. Okay, Andrew got it. It's going to be some random high port. So this is what we call an ephemeral port, in that it uses a random high port to actually create a connection to another device, because it doesn't, you can't really set one in stone. There are different ranges for TCP and UDP, but TCP is high up there. But yeah, so I guess I'll do a wrap up. So we talked about what networking is. It's basically sharing resources, right? You're not, we're sharing resources efficiently. If all these devices are on the same network, we can like send files to each other, send pictures. But yeah, it essentially is sharing resources and being able to communicate with other people. Important networking devices, we talked about switches, routers, firewalls. We talked about the OSI model and the TCP IP model. So switches would be layer 2. They work with MAC addresses, whereas routers work with IP addresses, which means they're layer 3. You'll hear these terms interchangeably, but that's pretty much what they are. Because routers connect multiple networks, they have to work with IP addresses, whereas switches work with endpoints. So they really only need to work with MAC addresses to communicate within that local area network. Firewalls, we're controlling what kind of traffic is coming into and out of our network. This can be really good for security and perimeter defense. But yeah, and then we learned about important terms: node, endpoint, the actual devices on the network, the gateway, what you need to use to get outside of your network, and the interface. So like you can have the network interface card, or like connect wirelessly through a WAP. But yeah, here's the TCP IP model again. We went through the application layer, which is just the actual application you're using. So if we're visiting a website, we would be using HTTP. Transport layer, how are we going to transport that data? We're going to transport it reliably, right, through TCP, and make sure everything gets to where it's supposed to be. Then we go into the network layer, which is the IP address. How are we identifying those devices on layer 3? And then data link, the source and destination MAC address. And physical layer, converting that kind of data into ones and zeros, basically. But yeah, more lingo. Addresses again, locate, how to identify your devices, protocols, TCP versus UDP, reliable and unreliable, or fast but really slow, but sends everything. And ports, identifying what services are actually on your device. But yeah, so these are commands I'll probably go over on Friday, just because we'll have a workshop and you'll have a VM to also try these. But these will give you network information about your device. And these slides will be here later. But yeah, so tools we're going to be using on Friday: Wireshark, TCP dump, basically analyzing the packets that are on the network. So when I say packets, these are like the information that is going across your network. I don't want to confuse you too much, but you can go into these packets and find information about the device who's sending it and who's receiving it, which I'll show shortly since we have a good amount of time. But yeah, so Friday workshop will be held on the data center's infra. So I will need to gauge how many people actually want to do it, so I can make the machines myself and also set up the environment. But yeah, so the interest form will be on Linktree. If you're interested in coming on Friday from 6 to 8, but I'll give you guys a little sneak peek of what we're working on. So again, Wireshark is a packet sniffing tool where you can analyze packets. As you can see here, I have this box called MPC1 because I used to be an NPC, but they're going to be automated. So what's happening here is the MPC is accessing FTP server. If you don't know FTP, file transfer protocol, it's basically accessing files on that server. And I have pretty funny files on that server, but what's going to happen is you're going to have a box, a Kali box. Don't worry. I'll probably block you from reaching the internet, so you can't do anything. But what you're going to have access to Wireshark. So, shoot, can Zoom see this? Okay. Oh, yeah. So you're going to open Wireshark, and we'll have a guide on like a quick start on how to start this, because this might be a little daunting to some people. But as you can see, I have an interface here called ETH0, and I'm going to start capturing on here, right? And then once I start accessing FTP on here, it's going to capture that traffic through networking magic you don't need to know about. But if I try to FTP into that box, if it's on, I don't know if it's on. Okay, I guess we're troubleshooting today, guys. So this FTP box is what I'm trying to access. And if I use the command IPA, I can see my IP address. I can also see it at the top. That's crazy. But I ran that command because I wanted to, but it's 109.200. So if I exit out of here and I try to FTP here, dang, it's denying me. But there should be FTP traffic on my Wireshark capture. As you can see, there's traffic over there because it's really cool port mirroring thing I did, but it's not here. But
Quick update, if you're having trouble seeing the board, you can just join on Zoom. It's a lot more clear. So yeah.
Here, I'm going to do this really cool trick. It's called turning off the box and turning it back on. But usually you'll see the FTP traffic, and when I log in, you can see the plain text creds on that. Right now, I don't know why it's not working, but yeah, it might work the next run, but we'll see. Yeah, because when we cloned all these boxes, they all got the same IP address, so it's kind of messing with some stuff. But oh, there you go. So if I do anonymous FTP means you don't really need a username to get on. You can put in any password. So if I put in anonymous as my username, if I put a password, it says I'm logged in successfully. So legal port command, I usually just go passive, and then it works. And you can see I have this file called bro.txt. And if I go to user here, you can see that, oh wow, that was my password. I like subconsciously typed that. That's crazy. Shoot. But yeah, so that's pretty much what you guys will be doing. There's going to be different services. We're planning on FTP, HTTP, and maybe Among Us, but that sounds terrible. But yeah, I'm pretty excited for it. If hopefully, if like you're brand new, we can try to help you get into it. We'll have like a quick start and like e-board members helping you out. But I think it's really cool. Yeah, but I think that's pretty much it. You guys want to add anything?
Yeah, I just want to add, with Wireshark, if you were to, after this meeting, were to take a look at it, learn more about it, it is a nice tool, but it also can be a bit, people have used it for malicious intentions. Your typical like coffee shop using a public network, and someone's there just, sniffing packets, collecting that data. So I'm just explaining that. I'm not saying to like go do it. With great responsibility comes with great power. Great power comes with great responsibility. So just think twice of what you're going to be testing this application. If you do happen to, test things out, and just prepare yourself for Friday's workshop. Yeah, that's just kind of like the niche in cybersecurity. We learn all these cool stuff and how to protect yourself or protect companies or our loved ones, in regards of the realm of cybersecurity, but can be utilized as well for ill intentions. So just a disclaimer. Don't do anything that would, or just like, don't do anything bad. But yeah, that concludes our workshop in regards of networking. Once again, if you guys haven't signed in, use the link tree link and try to become a paid member. Lots of great benefits, and we'll see you then on.
Also, if you haven't already, please use the membership form. We have to create accounts for everyone that attends Friday workshop virtually or in person, and we would like to have the accounts created already. So we just walk in and start. So if you're thinking about coming Friday, just sign up and we'll have an account for you. Thank you.